how to utilize the simulator to enforce the embedded system deployment. So today we are going to take care of how the embedded system is wired, and basically how to use the Arduino microcontroller to implement embedded system. So today we are going to look at deep architecture of how embedded system Arduino board looks like, and some of its key components that basically will be utilized in implementing a complete workable embedded system. Having said that, I would just want again for you to confirm that you can hear me, and so that we can begin class officially.
Loud and clear.
Thank you so much, Gregory. So I think we can begin. I will share my slide. And I would also want you to confirm whether you've been able to see the slide on your classroom this week slide. I would also want you to confirm that it is accessible and you can be able to have a look at it. Anybody to confirm that the slides for this week, this particular slide we are going to deal with this week, is shared? Can anyone confirm that you are able to see week 7, week 9 slide?
We cannot see it.
So if you go to your folder, there is a folder in the classroom written CSE 327. Can you see that folder?
Yes.
Inside it, can you confirm that there is a slide for week?
Yes, there is.
7-9. Okay, thank you. So I think that will be in order. I wanted to confirm that that is in place. And can you confirm that you can be able to see my screen?
Yes.
Good. So to begin, during this particular class, we are going to look at the advanced embedded system architecture. And with that, we're going to look at the Arduino microcontrollers, the architecture of the Arduinos, the interfacing with the computer system, and later, I think this is where Dr. Mburu is going to come in to look at the programming aspect of the Arduino. So this will do side by side with him, the last component on this particular agenda. So this is how the Arduino microcontroller looks like. And I would also ask you, if you get some time, you can visit the labs and have a physical look at these microcontrollers. We have quite a number of them in there. You can talk to Kamau, you can talk to Ken if I'm not available, and they'll be able to show you how this microcontroller board physically looks like. So as we had seen earlier, that Arduino is an open source electronic platform based on easy to use hardware and software. And this one was actually started all the way in 2003 by David and Massimo. So these are the two guys which literally came up and designed a simple board that would provide a cheap and a flexible way for students and professionals to learn the embedded system. So if you look at this board, it's not complex. It does not have very many things. What it has is
Excuse me.
yes.
We are seeing a screen whereby on your file explorer you've opened a folder, but we can't see a
Can't see
presentation.
the slides.
Oh, okay.
Yeah.
Oh, sorry. Let me have a look at it again. I think the problem is sorry for that. Thank you. Let me have a look at it again.
Can see the slides now.
So you're able to see my screen, confirm?
Yes, we're able to.
Okay, good. So as I was saying that to begin, let me just try to pick it up from where I had started. So this basically is our first slide. And on our first slide, what I say that this week, from this week to the next week, actually to the subsequent weeks up to, I think, week 8, we are basically going to look at the Arduinos, the architecture of the Arduino. We're going to look at the Arduino microcontrollers, the architecture of the Arduinos in general, and interfacing the Arduino with our computer system. And lastly, I did say that we are going to look at the programming aspect of the Arduino board. So as I was saying, that this is basically how the Arduino board microcontroller looks like. And as we had said, that Arduino is an open source electronic platform based on what we refer to as easy to use hardware and software. And this started all the way in 2003 by two guys. This is Banzi and David. Their main reason or their main intent was to provide a cheap and a flexible way for students and professionals to learn embedded programming. So Arduino boards come ready. Actually, it reads both inputs and outputs. It comes with already set light on sensor, finger on button, or what we call a Twitter message, and in turns all that into an output. So that is what we are going to see. How are we going to read inputs using specific LED lights? we're going to see how we are going to put a finger on a button to be able to have specific ports on these particular boards giving an output. We're also going to see how the light on a sensor is going to change or is going to implement a particular activity. We can use this to implement instant messages like Twitters. You can be able to have your Arduino send a specific message to end users with specific accounts at the end of it all. So this is done on the programming part of the Arduino. So we can also be able to see how to activate a motor to start running with a specific command on the Arduinos, the LED lights to go on and so forth. So this can do so much, and we are going to see quite a number of pins, input pins, that you can be able to tie a particular code to it for it to give a specific output at the end of it all. So first of all, I would just you have a look at the Arduino in general, what is there, and we are going to learn each and every component on this board so that when it comes to programming it, you know what are you dealing with and what are you handling at every one point. So the Arduino microcontroller, you can tell this board what you want it to do by sending a set of instructions to the microcontroller. And on this board, we are going to see which component is referred to as a microcontroller. So Arduino has a programming language based on wiring of this board and the Arduino software based on the processing. So what happens is that how this works is, what do you give it in terms of the language or the code? The wiring aspect, what have you connected to which component? And how do you articulate the software that is basically on this Arduino to implement what you want at the end of the day? So all that, we are going to look at it in detail as we move forward. So this thing called the Arduino microcontrollers is a very interesting thing. You can work with it basically just like a student, like currently you are students, maybe to pass embedded system class. That is it. The guys who'd want to play around with it, like this particular class, I noticed that there's some few students who'd want to play around with this particular board and get some specific outputs, not just for the sake of learning, but as a hobby. There are guys who basically do enjoy programming in Arduino, so it gives us the programmers. There are architectures who comes up to be able to see what they would want to change on the existing board and add additional components on it. And again, there are big professionals who basically study Arduino for research purposes to make additional contribution to what has already been implemented. So Arduino was born in one of the easy and basic institutes, Ivrea, and this institute gave out such a very interesting design on easy tool and prototyping aimed at students without a background in electronics and programming. So for you to run with this particular board, you basically don't need to have the basic knowledge of electronic. As much as we say you also don't need to have a basic of programming, but you really need to understand the concept of data structures to be able to handle how to interact with this particular board. So I know electronics, basically you do not need to be proficient, but you just need to understand what is positive, what is negative, and so on. And again, on programming, you just need to understand how data structures is carved out. This will be able to help you and understand on how Arduino microcontroller chipsets are operating. So many people are coming in now to adapt to this microcontroller. This is because it has become one of the easiest and a friendly board that can be utilized to implement a workable embedded system. And basically, this board gives us what we call a simple 8-bit interfacing. And when you talk about 8-bit interfacing here means it's only able to transfer small bytes of characters from one point to another. And initially, when we began this class, I told you that you really need to understand how computer architecture is designed and how it works. You need to understand basically how peripherals talk to the microprocessor, which bus moves which particular data register from what point to what point, what is the function of the controller bus, what's the function of the address bus, what's the function of the data bus. So if you'd be able to get those three basic components of the microprocessor during your computer architecture, then you will clearly understand what 8-bit board is all about. So this board basically can produce an IoT application, and basically you know what Internet of Things are all about. The wearables, those are the watches and so on, the 3D printers, and basically the embedded environment. So as we continue doing this course, I still urge all of you to go back to your computer architecture class and look at the microprocessor in detail. Try to look at how the registries are working, how the ads are working, how the basic buffers, memory buffers are working on the microprocessor. So with that, then bring it in here and you will be home and dry in terms of how many bits can move from the microcontroller to the input-output interface, and will be able to automate or produce an IoT, a wearables, a 3D printing, and even a basic environment for the embedded system. The big question comes in, why Arduino? So Arduino provides a simple and accessible user experience. Very simple, very accessible, and you will be able to see how that's come up. So it has been used in very many different projects and applications, like we've seen the wearables, the IoT applications. It has software that is easy to use for beginners, very flexible enough for advanced users. It runs on Mac, Windows, and even on the Linux environment. And I believe all of you understand the architecture. This still takes you back to the operating systems. And with the operating systems, you'll be able to understand how the Mac architecture is built, what we call the kernel, the Windows architecture, and the Linux architecture. But would somebody tell me basically, out of these three operating systems, what is the language used to build their backends, if I may ask? Anybody who can answer that? And I believe now at the third year, you'll be able to understand fully all the applications and their kernels and how basically they send and receive instructions from users and from the backend. So what would you say? Mac, Windows, Linux? How would one explain the backend architecture? Which language is used to design this? Can I have a volunteer?
I think low-level languages like C or maybe
C, Rust, and a bit of assembly.
Good. So that's it. That is it. So those are the basic languages which are being used. So that's why you see you are being taught what we call assembly programming. So don't always, I always tell students that every unit that is being offered at the department, kindly link it to the other unit and be able to see what is the rationale of these guys having designed this course for us to do. So you can see, like, now we are talking about the Arduino's microcontrollers, but we keep on talking about the operating systems, and we keep on talking about the computer architecture. And then now something is again coming up, the assembly language, which I believe you learned in your second year class. So always try to bind all these courses together and see what do you get at the end of it all. So this Arduino also allow teachers and students to build low-cost scientific instruments, both in chemistry environment and physics environment. So they use both physics and chemistry principles, or to get started with programming and robotics. So with all that put together, then you'll see Arduino to help you implement all this. So it allows designers and architects to build interactive prototypes. Musicians and artists use it for installation and to experiment with the new music. You can be able to see how powerful now the embedded systems come in. It allows anyone to start exploring just by following step-by-step instruction of this kit and sharing ideas online, and you'll be able to be up and dry in terms of the functionality of the Arduino system. So there are other microcontroller platform, Parallax, Basic, Stamps, NetMedia, BX24, FeedGates, MITS, Handyboards, but often offers some advantage that are included. Like there are some few advantages that would say that Arduino have over all these other microcontroller platforms. So you'll find that the Arduinos are not expensive. If you go and check the cost of Parallax are very expensive. What I know is BX24s are not very expensive. I've never checked the FeedGates, but what I know is that the BX24s are becoming cheaper of late. I'm yet to get my hand on one, even though getting them locally is not very easy. But Parallax are not cheap, they are very expensive. Handyboards from MITs are not very much available in our continent, but I believe those who go outside our boundaries, like the Europe and the Americans, would be able to get the handyboards. You can be able to check what are the architects of these other boards compared to the Arduino. But what comes out very clearly is that Arduino boards are cheaper than other microcontroller platforms. The Arduino boards are cross-platform in that its IDEs can be able to run on both Mac, Linux, and Windows environment. Simple and clear environment for programming. We will see how easy it is to interact with Arduino programming language. But you're also free to have a look at these other languages that can be used to program, like NetMedias and FeedGates, and see what is the difference between those other platforms compared to the Arduino programming language in terms of implementing a workable IDE on embedded system. So I would pause there and ask if somebody has a question. Any question? Yeah, Edwin, I always find your name first on this list. I don't know why. Do you have any question?
I don't have any question.
Aduma, ask something.
I'm good, thanks.
So you understand the architecture of the Arduino system? Aduma?
Yeah, I'm learning.
You're learning.
Yeah.
It's good to know. Alem, say something.
I'm good.
You're good. You understand the concept of Arduino microcontroller?
I'm learning.
You're also learning. Okay. Wanyama. Indeje.
I have no question at the moment, so.
Okay. Edith?
I don't have a question.
Okay, so I think we can continue and see more about the Arduino microcontrollers. So one of the things that we've actually seen is that Arduinos are open source, and at the same time, they use what we call extendable software. So Arduino softwares are always free. Can be able to go to the open website for Arduino and would be able to get this particular source software. So it is very extendable in the sense that you can be able to use other libraries like the C++ libraries, and we will be able to see that when we initiate the coding aspect of this particular platform. So the hardware for the Arduinos are published under what we refer to as a Creative Commons license. So experienced circuit designers can make their own version of the modules and extend it and improve it. So basically, it is working on what we refer to as CCL, which basically allows people who are more experienced on how the Arduino microcontroller works for them to build on top of this particular existing environment. So the architecture of Arduino. So from my design, the microprocessor that is sitting on this particular board is 80 mega 328 processor. The one that we are going to use for learning is Arduino Uno version. And from this particular architecture, you'll be able to see a few things, which I think we're going to look at them in details. You'll be able to see the pins on this other side. And subsequently, the additional pins on this other side. So we are going to see how to interact with these pins. But again, before you interact with all the pins on both sides, it has additional components, like you have to power it. At the same time, when you power it, how do you know it is powered? You'll be able to have light emitting diode, which is inbuilt to be able to show you that your specific board is actually working. So just to mention before I leave this page, you'll realize that we have both pins on the end, and these pins, they are what we refer to as the analog pins and the digital pins. And basically, we are going to see how to interact with both the analog and the digital component of Arduino. And when we were starting this particular class, I believe we did explain the reason why this board has both analog and digital pins. So just to bring up to speed, can somebody actually reaffirm to us that we understood the reason why this board has both analog and digital pins? Just to bring us up to speed, so that as we move forward and we start using these particular pins, then we'll be knowing exactly what we are working with. So anybody to explain to us why we need the A0 to A7 pins, and why we need the D's D0 up to D16 pins? Anyone who understood when we introduced embedded system on Arduino what we need to?
I think it's to allow for the digital to analog conversion, which, because the computer understands digital form of signals, so that, sorry.
Oh, sorry, Greg, the young one is not allowing you to.
Yeah. But it's something to do with, since digital, sorry. Since the digital data, Andres, silent.
Gregory seems to be in a messy place. Any other person? Yes, Doug?
Yeah, it's because in terms of electronics, there's analog electronics and digital ones, which I think from digital electronics, are made up of ones and zeros. So that's why they have an analog and a digital side. Because, for example, a potentiometer, it works using analog signals as opposed to something else like a transistor.
Good. Jerry, what do you have to say?
I also wanted to say the same thing. It's for converting, say, digital or analog signals inputs to the digital or analog outputs.
Okay. Yeah. So I think you're all right. So basically, the analog components are quite a number in embedded systems. And since the microcontroller basically understands the digital aspect, and that is the only thing that it can be able to interpret and gives us an output, then we would want to have some of these components that are actually implemented on an analog actually to also give us an output. So for this to be controlled, or for us to have something like a potentiometer to be controlled by a microcontroller, then we really need to have ports that allows what we call an analog input into this microprocessor for processing. So because we can't connect them on the digital pins, we have to get an interfacing, or we have to convert our digital pins into analog pins for it to work. So in this case, the board is already made a bit flexible to be able to give you existing pins that if you have an analog device that you'd want to be controlled by this 80 mega processor, then you just need to slot them there, and then you just need to tell the microprocessor that, listen, I have this analog equipment on the analog side that I'd want it to do ABCD. So that is why we find it is very important to have the analog pins. The digital pins still explain itself. They're those components which are already consuming what we call the digital signals. So they also have their parts. You just slot them in onto their pin zone and giving them the necessary codes and language, then they'll be able to be interpreted and give us the suitable output. So we've looked at that board, and on your free time also, I'd want you to create some time and go through the board again and see what are the basic functionality of each and every pin on this board. But again, we'll also, as we see it in class, I would also want you to create time and be able to understand this board in detail to make your work easier, because it will not be very flexible for you if you don't understand the pure architecture of your board for you to implement the programming part of it. So the board comes with some components which we've seen. It has a DC jack power. So this is basically a port that you can use to power your Arduino board. It is a DC power. You slot it in there and it will be able to power this. And the DC power should not be more than 12 volts. It has its own voltage regulator. So this is just electronic. So the voltage regulator ensures that the board is fed with the required amount of voltage. So you'll find that if you try to power this board with the high voltage, then the very first component that will go is the voltage regulator. This is just to protect the board from further damage, because if you spoil the microprocessor, then basically it will not be very easy to replace a microprocessor. You will end up throwing this particular board away. We have the USB port, and in so many scenarios, we'll find that we can also use the USB port to power this particular board. So it can be, the USB port can be multi-user. It can equally be used for powering. At the same time, it can also be used to read or reprogram our Arduino board. So at one point, you'd want to reprogram this particular board, maybe upgrade it to another version of Arduino in terms of software, then you'd still use this particular port to be able to do that. It has a reset button because such boards would always need a reset in one way or another. Apart from that, it has an oscillator, crystal oscillator, and you all know the function of an oscillator on any electronic environment. The ATmega16, this is basically what I always call the coprocessor or the math processor on this particular board. We have the I to C communication pins. We are going to see very interesting pins. We are going to see their functions. We have the analog, what we call the ARV port, the analog reference voltage, the RF pin, we are going to see it. The ground pin, very fundamental in this board. You can see the digital pins, and please note that digital pins start from 0 all the way to 14, and the 14th pin is the ground pin. We will see the different. There are some pins, and I believe you can see my board well. There are some pins with a tilde. Yes, don't just think those tildes are just there for the sake of it. You're going to see the function of those pins. They are digital pins, but we call them the PWM, the pulse modulator pins, wave modulator pins. You're going to see their functions, very good pins. These are the pins that I want. It has what we call, how do I explain this? it can convert an analog to digital. So if you have, there's some analog components that you're going to use here, but these analog components, they're supposed to give out a digital output, correct? So that analog component that would be able to output a digital output directly, you put them on what we call the PWM pins so that it will be able to function very well. The TX and the RX pins, the serial communication pins, they're down there. We have an indicator on the board. The head for pre-programming these boards are also there. The in-circuit serial programming heads are down somewhere here. Can be able to have a look at that. On this other side, we have the analog pins. They're only 6, A0 to A5. We're going to see how beautiful these pins are. Then we have the micro controller here, the big chipset. Remember, this microcontroller can be reprogrammed, what we call the 80 mega to 28. So this is the version that we have here, and there are other versions. Then on the other side, then you'll be able to see you have power sources. So input, output ref, the reset, the 3.3 volt, the 5 volt, the grounds, and the VIM. Very interesting port for powering your components that you are using to implement embedded system. So I'd want you to take time, create some reading time, visit the engineeringproject.com website, and further have a look at, I would want you to master, to just say that word, how these pins work. I'd want you to carry it as an assessment on your own and figure out what is the work of the input output ref pin, what is the work of the reset, the 3.3 volt, the 5 volt, the grounds, and so on. And I would also want you to have a look at the digital pins all the way from 0 up to 14, and have a look at the I to C communication ports and basically how they work. So you looking at them will give you a very humble time to be able to implement your Arduino environment. Okay. So very fast, I would want us to have a look at the pins. And we've talked about all this, but it's good again for us to revisit them and see what are their core functions. So on the Arduino Uno board, the technical specs that it has, one, the microcontroller, and you've seen how the microcontroller looks like, the 80 mega 228 chipset, the oscillator, which is the clock. Yes, the clock that sync quite a lot on this particular board, which runs at a speed of 16 megahertz. So that's a million instructions per second. This board operates at a voltage of 7 volts. Okay. It takes an input volt. So remember, generally it operates on 5 volts, but a scenario whereby you have a servo motor that works at maybe 9, 10 volts, then you can't depend on the 5 volts that the Arduino, it can flex up to 12 volts. So that is you'll realize that will be the importance of the VIN pin, very important now, because the VIN pin will be able to give us more power that we can utilize to power additional component on our board. The digital pins we've seen, in, out pin, there are 14 of them. The analog pins, there are 6. The PWM pins, which I have explained, that the PWM pins are the pins with the tilde on the board. You've seen them. There are also 6. If you look at our board here, you can see the tildes on the digital part, correct? So that basically gives you what we call the PWM pins, and I explain what PWM is. We look at that in further. The power pins, you say that this board can work with the 5 volts. It can work with 3.3 volts. It can work with more than 5 volts. So if you want to use more than 5 volts, then that is where the VIN pin comes in. And basically, the ground pin is always the negative pin on our board. The communication ports, correct? We have UART 1, SPI 1, I to C 1. So I would want you just to note, I want you to write a small notes or do kind of a small assignment. And I would want you to further write something about the UART pin, the SPI pin, and the I to C pin. So that will be our small assignments that I would expect everybody to tackle. And in our subsequent class, I will be able to throw questions to specific students to be able to explain for me in details what those pins are all about. It has a flash memory. This is the EEPROM, the programmable memory of 32 KB. And this is where we put our bootloader. The SRAM, the EEPROM 1 key, 1 kilobytes, and then it has what we call an in-circuit head, which is 1, and then the power source, which we say that they are the DC jack and the USB port. So those 14 parameters are very important, and I would want you to take your time, understand each and every component on the Arduino board. So this is just basically the same board that we've been seeing. So Arduino Uno is a microcontroller board. It's based on what we have seen, an ATmega 328, but this is just for Arduino Uno board. There are other boards with a different microcontroller. So don't just say that Arduino only has one microcontroller. You can also read more about several microcontrollers found in different types of Arduino boards. This was actually the very first Arduino board developed. And Uno in this scenario mean 1 in Italian. Software. So Arduino Integrated Development Environment is used for writing, compiling, and uploading codes to Arduino boards. It is free, as we had always said at the beginning. It has basically an it operates on 5 volts, but as we had seen, there are several outputs or inputs that would want to consume more than 5 volts. So we say between 7 to 12 volts. So Arduino Uno has a maximum current rating of 400 milliamperes. Therefore, the load should not exceed this current rating. And that if you put more load more than 40 milliamperes, then you'll be able to spoil this board. So this takes you back to your physics class, and you'd want to do the rating for this particular board and see how much is 40 milliamperes, which actually is a unit that you've already discussed in your first year. And I believe this is now, it should be able to help you basically to understand what is this current rate that should not be exceeded on this particular UNO UNO board. So the pins, the architecture pins. So we say that it has a crystal oscillator of 16 megahertz, which is its operating frequency. And again, I would say that this is something that each one of you should be able to understand. What is 16 megahertz frequency that this board is operating on, correct? So you really need to understand what's the function of the crystal oscillator. And once you understand what is a crystal oscillator, then there's frequency speed, and how does this frequency speed affect the operation of this particular board. So Arduino Uno has pins. We've talked about this. Now you should be able to know that it has 14 digital pins, the D0 to D13. It also has 6 analog pins, the A0 to A5. It also has 1 reset pin, and you know the reset pin, which is used to reset the board programming program. So programmatically, if you would want to reset everything which is on that board so that it restore it to factory settings, then you'll use what we call the reset pin. In order to reset the board, we need to make this pin low. So what do we mean by making the pin low? Correct? Anybody who can help me explain that? By making the reset pin low means what? It's a big class. I should have people answering such questions. What do you mean by making a pin low?
Voltage 0.
Easy. That is it. So it also has 6 power pins, which we have seen, very fundamentals, and you will be able to interact with them. So out of the 14 digital pins, we say 6 are used for generating palms width modulation, what I refer to as the PWM, to get analog result with a digital means, correct? And this is what I had earlier explained. And then they always have what we call an 8-bit resolution. So the PWM pins in Arduino Uno are the D3s, the D5, the D6, D9, D10, and D11. And I say to identify them on any board, they will have a tilde next to them. So Arduino Uno comes with 3 types of memory associated with it. We have the flash memory, the static RAM, very important. Static RAM. What is the function of a static RAM? Anybody who can answer that quick?
To store data when memory is lost.
Store data when memory is lost. Yeah.
I meant power, not memory.
Sorry?
I meant power, not memory, when
Not
power
memory.
is lost.
When power is lost.
Yeah.
And again, I would also add that we use it as a cache. Correct? It's our cache. This is the fastest memory on this particular board. And you can see the cache does not need to be big. If you look at the history of the microprocessors, and you'll see that from the Pentiums, when we started the Pentiums family, Pentium 1, Pentium 2, we did not have the caches. The caches are that very fast memory, static memory that would be able to restore where the microprocessor, this is the darling of the microprocessor, that I have a lot of weight. Can you carry this for me for a second or for microseconds before I finish this? So in many cases, I would want you to understand deeply the architecture of the microprocessor. And if you understand it deeply, then one of the things that will come out very well is that what is the function of the SRAM, what we call the static RAM, and what is the EEPROM, the erasable, the programmable RAMs, or the programmable memories that we have. So in these scenarios, the EEPROMs would basically act like the DRAMs or the dynamic RAM in this particular environment. So SRAM will be the static ones, then the EEPROMs will basically the programmable. These are the ROMs, or the ROM that carries the bootables. You can actually change and actually reprogram it back. I always love computer architecture because the concept of computer architecture is it's something that basically you can put your hands on it and you reason up with it and you run with it. So you can join me in loving the microprocessor architecture, the computer architecture, and this would enable you to understand deeply how embedded system components operate. Arduino Uno supports 3 types of communication protocols, which I've given you small assignments to go and look at, to help you interface Arduino with the third-party peripherals. And when you talk about third-party peripherals, is that I would want to bring in additional components that do additional tasks that would support my board, correct? I want to bring in a pin that would be able to add more voltage, or I would want to extend my RAM, I would want to extend my microcontroller. So this is where these particular pins come in. So data sent one after the other on the serial protocol. This is what we call the SPI. Then we have the integrated circuits, what we call the square C. How would you call it on our current technology that we have? Basically, you have them on your phones. The C port, correct? That you guys are using. So alternatively, it's called I2C or IIC. It's synchronous, it's multi-controller, multi-target. It does so many things. Packet switches, single end, serial communication bus. So this actually port was basically discovered by Philips Semiconductors all the way in the 1982, even though it was not fully implemented in other devices that currently we are actually consuming this specific port that can do a lot. So these are the ports that I would want to interface, just like you would be able to interface your phone with your computer using Type-C charger or Type-C pin or Type-C port. So this, if you get that concept, then it's the same concept that you should bring in here, and you'll be able to understand how the 2C protocol work. The SPI protocol, the serial peripheral interface, is synchronous serial communication interface specification used for short distance communication, primarily in embedded system, and it is full duplex. Full duplex means that it can send and receive at the same time. So you can further go ahead and look at the specific pins on your microcontroller. You can see the way the microcontroller is designed, all the pins on the microcontrollers, they're labeled, and there are scenarios whereby a student would want to design a device that controls other things, but you do not want to use the Arduino chip or Arduino assembly chip. You'd only want to get the microcontroller and reprogram this microcontroller to do a specific task. So with that, then you'd be able to understand each and every pin on the microcontroller, from basically from pin 1 all the way to pin 28. And if you understand the function of each and every pin, then you can freely pick out this microcontroller and use it to implement something without the utilization of the entire Arduino Uno board in this particular scenario. It's good you take time again to read each and every function of these pins, correct? I would sometimes not really in a technical way, but I would ask you, what is the function of PB6 pin on port B of the microcontroller. So when I tell you to read and try to understand these things in detail, then it's for your benefit to be able to use this particular component to implement something beyond the microcontroller assembly board, but on its own. Okay, I will pause there. I'll pause in there. And if anybody has a question, if there's something that is not coming out well, this is the time to ask so that we be at par with what we are learning today. Any question?
I have two questions. One,
Mm-hmm.
in the SRAM and the double EEPROM, are those capacitors and transistors? So is the double EEPROM a transistor in this case, since you said it's dynamic RAM?
Yes, that is good because it is programmable. It is a transistor. You would say so. That is correct.
And then I don't understand how we have 6 analog pins.
Mm-hmm.
And then, so is the work of the pulse width modulator to like increase the bandwidth? I don't understand that.
No, so there are two. The analog pins is basically to connect the analog component. We'll see several analog components that we'd want to use, like the potentiometer, as the other student had indicated earlier. You'd want it to go to the analog component. But the PWM, these are pins that we want them to behave differently, correct? We'd want to feed them with analog signal, but we want them to give us an output which is digitally readable by the what? By the microprocessor. We also have such components. So as we move forward, you'll realize that there are components that you'd want them to behave like a digital component. But in that scenario, you can only put them on those particular pins. But this particular component is an analog component, but basically you would want it to give you a digital output. Remember, the analog pins basically is a servo motor, for example. It just rotates. That's just analog thing, correct? But see, you have an LCD screen, correct? So this LCD screen would be able to have an input which is analog, but basically would want you to produce this as a digital output. So does that make sense?
Yeah, that's actually clear.
Good.
Thanks.
Okay. Any further question? So I'll go a bit on the board and then I think we'll break. So it has the 80 mega 328 microcontroller. We've seen it has a timer. We've seen it has a counter and it also have an interrupt. These take us back again to our programming to our operating system, whereby you learn about counters and you learn about interrupts. We have the PWM, which we've just explained, the CPU, the input-output pins based on the clock we have seen there, 16 megahertz, that help producing more frequency and the number of instructions per cycle in this particular board. We also see it is an open source platform. Anyone can modify, optimize the board to give specific output. So it has a built-in regulation feature that keeps the voltage under control. And we saw on that board, we have what we call the voltage regulator that would not allow more current beyond 40 milliamperes to get into the board. It has a reset pin, basically to reset the whole board, which we've seen. We've seen the 14 pins, the 6 pins incorporated in the board that allows the external connection with any circuit within the board. These pins provide flexibility and ease of use to the external devices that can be connected through these particular pins. So there is no hard and fast interface required to connect devices on this board. Just plug and play, and then you program it, and then that is it. We've also seen the pins, the 6 pins, analog pins, and it comes with 10-bit resolution. The analog pins measures from 0 to 5 volts. However, they can be configured to a higher range using now. Do you remember the pins for the power pins? Now, this is where this one comes in, what we call the analog references. So they can be configured to a higher range using another pin called the ARF pin. So if you check on your board, you're going to see the ARF pin. So you can see what is the function of the ARF pin. The ARF pin can be used to configure to a higher voltage. What do you configure to a higher voltage? The analog pins. You can change them to consume more voltage as per the 0 to 5 voltage that are defined for it. Only 5 volts are required to turn the board on, which can be achieved directly using the USB or the adapter ports that you saw. However, it can support an external power source up to 12 volts, which can be regulated and limited to 5 or 3 based on the required project that you're doing with that particular board. So, further description of the Arduino board. So there are several input-output digital and analog pins placed on the board, which operates at 5 volts. These pins comes with a standard operation rating range between 4 milliamperes to 40 milliamperes. Internal pull-up resistor are used in the board that limits the current exceeding, then gives operational condition. Too much increase in current makes the resistors useless, and with this basically can be able to damage your board. Light emitting diodes. Arduino comes with the light emitting diode. So this light emitting diode is just some light on the board. If you power on your board, then you'll be able to see it turns green, it turns orange, or it turns white. So it depends on the color code or LED that is being utilized to show that the board is functioning. So we are all going to see this and interact with it. And you see the LED, which is connected through pin 13. So provide a higher volt value to the pin, which turns it on, or a low value, which is a 0, which turns it off. So digital electronics, high, low, you also need to have that concept well articulated. VIN is the input voltage provided to the analog board. And we've talked about it. It is different from the 5 volt supply through a USB. So VIN pin is used to supply voltage. For example, if a voltage is provided through a power jack, it can be accessed through this particular pin. So that means that the VIN pin is very important. If I need excess voltage apart from 5 voltage, then I've given in this board a 12 volt using my jack on the board. Then if I want to consume that power, then I can only consume it through the VIN pin. And this we'll see practically on our subsequent practical class. So the Arduino pin further description, the 5 volts, this board comes with the ability to provide 5 volts regulation. 5 volt pin is used to provide output regulated volt. The board is powered up using 3 ways. 1, you can power the board using the USB. 2, you can power the board using the VIN pin of the board, or the DC jack, which is also on the board. So the USB supports voltage around 5 volts, while VIN and jack pin support voltage range between 70 to 20 volts. So you need to get that right. So if I need more volts on my board, then I use the jack port or the jack pin, or I use the VIN pin on the board. It is recommended to operate this board actually at 5 volts, just to be on the safe zone. Note that if a voltage is supplied through 5 volts or 3.3 volts pin, the result in bypassing the voltage regulator that can damage the board if the voltage surpasses its limit. So that means that 5 volts is suitable for this particular board, and it does not affect anything when it comes to operational within the board. But if you supply 7 to 20 volts, then those are very high volts that must pass through what we call the voltage regulator to ensure that the required voltage is the right voltage is consumed in the board. The ground, the G and D, these are the ground pins. More than one ground pin are provided on this board because in several scenarios, you'd want to have a complete circle by providing both the negative and the positive voltage. So further, you'd also want to see the reset pin, which we've talked much about it. So this pin is incorporated on the board, which reset the programming running on the board instead of physically resetting on the board. So the ID comes with a feature of resetting the board through the programming. So you can be able to use your interface to be able to reset the Arduino interface. You can be able to use it to reset your board than physically going to press this pin on the board. You can just use your IDE interface to reset your board. So input-output ref, this pins is very useful for providing voltage reference to the board. A shield is used to read a voltage across this pin, which then select the proper power source. So as we had seen earlier, these are additional pins that we can use to provide power to the what we call the analog component. We want to give more voltage to an analog component, then the input-output ref pins comes in handy. We have also seen the PWM pin provided by 3, 5, 6, 9, 10, and 11 pins. So these are configured to provide 8-bit output PWM. And the other thing that you also need to note that how much bit do these pins provide? We have seen the analog pins would be able to give us 10 bits. We are now seeing that the PWM pins would be able to give us the 8-bit pin. So the analog is allowed to give us 10 because of the parity check. When we talk about parity check, we have what we call parity errors. We might have one pin sending or one bit sending, but it failed. So we not have to have what we call a checksum checkup so that it be able to push the other one so that we have the required 8-bit or 1 byte at the end of it all. So again, technically, you should also be able to understand how comes the analog is allowed to send on 10-bit. This is because of errors. One might fail to reach, then the other one will be following it with the same signal to it for it to achieve its objective. So you also need to understand why do we need 10-bit on an analog and why do we need 8-bit on digital pins. Digital pins are sure bet, as you would say. So if you send it, you'll be able to achieve the required output. So this is the concept. The SPI, we've also seen them. And we've seen that the serial peripheral interface, there are 4 pins. You will see them on the board. The SSS, the MOSI, and the MISO, and SCK. So I would want us multiple, the MISOs, the MISO, and the MOSI. This is why I ask you to read more about the SPI. So in our next class, I would want you to tell me what's the function of pin 10, the SSS, and pin 11, and pin 12. And mostly, if you check the Arduino board, somebody can tell you, I'm not seeing pin 11, I'm not seeing pin 12, I'm not seeing pin 13. If you want to see these pins, you read the opposite side of the board, and you'll be able to see these pin labels on the other side. So on top of reading and writing something small about the SPIs, I would also want you to look at the 4 pins. What are their functions? And what do they provide in terms of the functionality of the Arduino Uno board? A ref is called analog reference. This pin is used for providing a reference voltage to the analog input. Very important. You also need to know why do we need additional pins in terms of powering the inputs of analog, because some of them might need more voltage. So what do? We use this additional pin to implement this. TWI is called two-wire interface. It's a communication. It's accessed through wire library. So this one can be accessed through A4 and A5 pins are used for this purpose. So what is the function of the two-wired interface? These are a few things that I would want to leave to you as assignments to be able to understand them in detail. So during our next class, I'll throw questions and individuals will be able to explain for us what is the function of these particular pins so that we learn them as a class and we understand them in detail. So we have the serial communication pin, the pin 0 and the pin 1, and then that is the RX used to receive data while the TX transmit data. So I would want to pause there. Actually, I would want to stop there. And I would want to field questions from you, because technically, if I'm asked, we should do this particular class supervision. We should also do some kind of hands-on. So as we learn or as we go through these pins, we should also at least put our hands on the Tinkercad and be able to see the behavior of each and every pin on this board. Okay, so I'll pause there. And anybody with a question can ask. Anybody with a question can ask.
For the project, supposing you want to buy components, is there a place you can recommend?
Talk to Kamau. Okay.
Okay.
Talk to Kamau 10. There are better place on shops that sell these components. The ones I knew was closed. So I believe Kamau and Ken will be able to advise you on where to get these components if you want to go for them physically. Okay?
Okay.
Good. Question, Ian Alpha Asiema. Can you say something in this class? Ian, are you there?
No question, sir.
No question. Sunday Joel, I'm asking questions. Do you understand the Arduino architecture? Do you understand the functions of the analog pins? Do you understand the functions of the digital pins? Joel. Okay. So can I go ahead again? Lucy. Any question?
No questions.
So you would be able to tell me that the Arduino microcontroller has how many pins? Lucy, how many pins do our Arduino microcontroller have? Any answer? It can even be false. We will correct. Lucy, I'm still on your case. Nank say 14. But Nank, if you say 14, are we talking about 14 being the digital pins or the analog pins. Yeah. Both them, there are many. If you talk of both of them, there are many. So Kyoko is telling me that we have the 14 digital pins and the 14 digital pins and 6 analog pins, one reset, one, which is okay. Those ones are just for programming our Arduino board. So this is actually now the concept. This is the concept I really wanted to come out clearly. I would want you to understand the pins that we use to program our Arduino, correct? Both the analog, the digital, the reset, the power pins. These are for basically for programming our Arduino Uno board. But when you look at the microcontroller itself, yes, the microcontroller itself, it also has its own pins. So just allow me to, now Sidma has got it right. There are 28 pins. So basically what I'm trying to say is that, let's just do this. Let me just go back here and come up somewhere here. This is what we are talking about, correct? So you should be able to understand what's the difference between the microcontroller itself. This is the microcontroller pins, correct? There are actually 28 of them. And this is the other thing that I was trying to say, is that you need to look at the grouping, the ports grouping, and you can go further and try to read. The reason why this is important for you is because I am going to tell you to program an LCD screen. And I want the LCD screen to display, this is our first embedded class. So this is our interactive class, reading on our embedded. So then you really need to understand what each and every pin produce, correct? On your ATM Mega microprocessor itself. So we really need to understand properly how these pins behave. And once you understand how these pins behave, then it will be very comfortable for you to implement any output on this particular embedded system. Correct? At least that's now is clear. Let me look at these other guys who are here. I know some of them just sit and are not telling us all they know. Onyango Anthony, can you say something about this? Anthony, your connection is bad.
No questions.
So can you explain for us what is the function of IOE ref? You should not have a question. Me, I have one. Yeah. What do we use IOE, input output ref pin, for? Should follow this class, should follow the class what we are learning about. Roman Juguna, what are you saying? What can you say about this class for today? Okay. So it's called Anthony. I think you've got an answer from the chat, the question I've asked. Craig Ochieng.
Yes.
What can you say about today's class?
Today's class, we talked about the architecture of Arduino. And we focused a lot of how there are various pins. There's the ground, there's the voltage for 5 volts and everything. There's the reset, then there's the digital and analog pins.
So can I ask you a question?
Yes, you can.
So did you understand the function of the VIN pin?
That is the voltage in.
Mm-hmm. What's it?
That is it's for powering the board itself.
Mm-hmm. With how many volts?
It can either be 5 or 3.3, depending on. Yeah, it depends.
Mm-hmm. So can we use it to give the board more voltage apart from 5, between 7 and 20?
I think there's a technique for that.
So if we were to do that, can we use the VIN pin?
I'm not sure of the technique. I'm not sure if that is the way, but I remember in your slides there's a way you mentioned.
Okay. Fair enough. Okay, thank you.
Welcome.
Let's see these guys. Daniel Jaramba.
Yes.
Tell us something. What did you understand? You know, it's simple. I mean, anything, all the concept. You can tell us a line or 2 or 3.
The use of the regulator to maintain the volts from the bin.
Okay. That's all?
Yes.
Okay. Thank you. Rian Silu. What can you tell us? Some guys are already running away, but it's okay. We are just learning here. Mutua. Alex. Do you have something to say?
Which Alex? I think we have many here.
So you now you are the victim.
No, I have nothing to say.
Anything you've picked in this class?
Yes, a lot.
One.
I see.
Okay, thank you. So I think we'll stop in there. If there's no any other question, we plan to meet in our next class. Remember, our slide ended on slide 25. So we'll pick from slide 25 downwards.